Welcome to The Explainer. Have you ever really wondered what makes Python dictionaries so incredibly fast and powerful? Well, today we're going to pull back the curtain and explore the advanced features that are going to level up your coding skills. Okay, so to get us started, let's frame this whole discussion around a really practical problem, the Scrabble sorting challenge. So picture this, you're building a Scrabble app. One of the very first things you need to do, right, is figure out which letters score the most points. And this sounds super simple on the surface, but it's actually the perfect example of why picking the right tool for the job is so important. All right, here's our data. It's all neatly tucked away in a Python dictionary we're calling Scrabble Score. It's pretty straightforward. The letters of the alphabet are our keys, and their point values are, well, the values. A is worth 1, B is 3, all the way up to Z, which gets you a cool 10 points. Okay, so what's the first thing you might try? Your first instinct probably is to just throw Python's built-in sorted function at the dictionary and see what happens. But when we do that, the result isn't exactly what we were hoping for. What we get back is a list of the keys, the letters, sorted alphabetically. So A, B, C, D, that's not what we need, right? We need them sorted by score. So the big question is, how do we get it to sort by the score, the value, instead of the key? Well, the answer lies in a really powerful dictionary method. And that crucial tool is the .items method. Now, what this little guy does is pretty cool. It completely transforms our dictionary into what looks like a list of tuples, these key value pairs. So instead of just having a bunch of letters, we now have a list of these pairs, A, 1, B, 3, and you get the idea. The key thing here is that it gives us access to both the letter and the score at the same time. Okay, now watch how this all comes together. We're using sorted again, but this time we're using it on Scrabble score.items. And check this out, this special argument right here. Key equals get Scrabble score. This little function is basically our instruction manual for the sorted function. We're telling it, hey, for each of those little pairs, don't look at the letter, look at this second thing, the score, when you're sorting. And of course, we add reverse equals true because we want the highest scores right at the top. And voila! This shows our solution perfectly. We've got our list of letter score pairs all sorted exactly how we wanted, from high score to lowest. And look right there at the top, Q and Z, both worth a whopping 10 points. Problem solved. But just organizing our data is only half the story. Let's switch gears a bit and talk about why using a dictionary here gives us a massive performance advantage. And I mean massive. So let's just compare two ways of getting a score. With our dictionary, it's super simple. We just ask for the score of P and we get the answer, bam, directly. But imagine if we were using two separate lists instead. We'd have to first search through the entire letters list just to find the position of P, and then use that position to find the score in the other list. Now, the reason the dictionary is so much faster is because of this magic under the hood called a hash table. Basically, Python takes the key, like P, and uses a super fast function to instantly figure out exactly where its value is stored in memory. It's like a direct phone line, not a game of hide and seek. It's a direct jump, not a long, slow search. And that little difference, it has huge implications when you're working with a lot of data. So we actually timed the list-based approach, running it over 6 million times. And having to loop through and find the index every single time, it took over 2.2 seconds to finish. Okay, now let's do the exact same thing, but using our dictionary this time. The difference is, honestly, it's staggering. It took just over half a second. That's it. That is a 4-time speed up. So the real takeaway here, the crucial point, is that picking the right data structure isn't just some academic exercise to make your code look clean. No, it has a major, measurable impact on how fast your program actually runs. Okay, so we've established that dictionaries are absolutely fantastic for these key value lookups. But what if your problem is different? What if you don't actually need to associate a value with a key? Let's think about a new kind of challenge. Imagine all you need is a big bucket of items. You don't care what order they're in, but there's one golden rule. Every single item in that bucket has to be unique. Absolutely no duplicates allowed. And this is the perfect job for a Python set. Just look at this example. We've got a list here with a bunch of duplicate A's and B's, but watch what happens the second we convert it into a set. Poof! All the duplicates just vanish. We're left with only the unique values. It's automatic. So this really clarifies the key difference, right? Dictionaries are all about that mapping, unique keys pointing to values. Sets are way simpler. They're just an unordered bag of unique items. A good way to think about it is like a dictionary that only has keys. But the real magic of sets, where they truly shine, is with their built-in methods for comparing and combining different collections. I'm talking about a whole suite of mathematical operations that are incredibly fast and super useful for data analysis. We're going to look at a couple of the most common ones right now. All right, to see how this works, let's dive in with two really simple sets of numbers. We've got a set we'll call 1, and it has the numbers 1, 2, and 3. Then we have another set 2 with 2, 3, and 4. First up, let's talk about union. You can use the union method or just this handy pipe symbol. What a union does is it basically combines two sets, creating a brand new set that has every unique item from both of the originals. So the union of our set 1 and 2, that gives us 1, 2, 3, and 4. Now, intersection is kind of the opposite. It finds only what the two sets have in common. You can use the intersection method or this little ampersand symbol, and what you get back is a new set with only the stuff that overlaps. So for our two sets, the intersection is just 2 and 3. And there are other really useful operations too, like finding the difference between sets. The things that are in one but not the other. All right, let's wrap this up with the key takeaways. First, if you ever need to sort a dictionary by its values, not its keys, items is your best friend. Second, always remember that dictionaries give you that huge performance boost for lookups, all thanks to hash tables. And finally, when all you need is a fast, unordered collection of unique items, a set is absolutely the perfect tool for the job. So that leaves us with one final thought. Choosing the right data structure for the job, it isn't just about being correct or academic. It can fundamentally, and I mean fundamentally, change the speed and efficiency of your applications. So now that you know when you should reach for a dictionary versus when you should grab a set, where in your own code could a 4 times performance boost literally change everything?